The welded steel cap sits flush with the ground on the Kola Peninsula in northwestern Russia, near the small town of Zapolyani, roughly 200 kilometers north of the Arctic Circle. It is not marked with ceremony. It does not announce itself with the scale of what lies beneath it. A person walking past it without context would give it perhaps 2 seconds of attention. A rusted industrial cap, bolted flat, surrounded by the decayed infrastructure of an abandoned Soviet facility whose buildings have been collapsing incrementally since the program that built them ended in 1992. Beneath that cap descends the deepest artificial hole in the history of human civilization. The Kola Superdeep borehole, designated SG-3 in Soviet scientific nomenclature, reaches 12,262 meters into the Earth's crust. To make that distance physically legible, if you inverted the borehole and stood its depth vertically above the ground, it would rise higher than 14 Burj Khalifa towers stacked end to end. It would extend well past the cruising altitude of commercial aircraft. It would place its upper end in the lower stratosphere, in air too thin to breathe and too cold to survive unprotected. And yet all of that distance travels downward, not upward, through solid rock, through geological formations that had never been exposed to any instrument, any light source, or any atmosphere since they were created hundreds of millions of years ago. The drill reached depths that no ocean trench, no natural cave system, and no mine in human history has approached. It penetrated nearly 1/3 of the way through the Baltic continental crust, reaching rock that formed approximately 2.7 billion years ago, when the Earth was less than 2 billion years old and the atmosphere above it contained no free oxygen. When the drill finally stopped, not by design, but because the rock at depth was hotter than expected, so hot that the drill bit could no longer maintain structural integrity, the Soviet scientists who had spent 24 years boring through the Earth sealed the hole and wrote up their findings. Those findings contradicted nearly every assumption that theoretical geology had made about the deep crust. The rock at depth was not what the models predicted. The temperature was not what the models predicted. And in a geological formation that, by every prior understanding, should have been completely dry, desiccated by billions of years of pressure and heat, there was water. 3 questions drive this investigation forward. What did the Kola borehole actually encounter that existing geological theory could not explain? What does the existence of water and unexpected geology at extreme crustal depth mean for understanding the Earth's interior? And, potentially, for the conditions that support life? And why did the most ambitious scientific drilling project in human history end not in completion, but in abandonment? And what was sealed inside when the cap was welded shut? The Kola Superdeep borehole was a product of scientific ambition amplified by geopolitical competition. Its conceptual origin lay in a fundamental question that had preoccupied geologists since the development of plate tectonic theory in the 1960s. What does the deep continental crust actually look like? And how closely does it match the theoretical models derived from seismic wave analysis? Seismic tomography, the technique of mapping the Earth's interior using the behavior of waves generated by earthquakes, had by the 1960s produced a detailed theoretical picture of crustal structure. Seismic waves travel at different velocities through materials of different density and composition, and by analyzing the arrival times and waveforms of seismic signals at surface stations, geophysicists had constructed models of what the crust should contain at various depths. These models predicted a clear boundary called the Conrad discontinuity at approximately 7 kilometers depth in continental crust, a transition from lighter granitic rock above to denser basaltic rock below, where seismic wave velocity increases sharply. The Conrad discontinuity was not an observed fact. It was an inference. an interpretation of seismic data that had never been verified by direct sampling. The only way to verify it was to drill there. In 1970, the Soviet Ministry of Geology authorized the project that would attempt exactly that. The site on the Kola Peninsula was selected for its geological stability and the accessibility of ancient Precambrian basement rock, among the oldest exposed continental crust on Earth, which would allow drilling to penetrate through geological time as well as physical depth. The American scientific community had its own deep drilling ambitions. Project Mohole, authorized by the National Science Foundation in the early 1960s, aimed to drill through the oceanic crust, thinner than continental crust, to reach the Mohorovi discontinuity, the boundary between crust and mantle. Mohole successfully recovered samples from the oceanic crust for the first time, but was cancelled by the US Congress in 1966 due to cost overruns and political opposition. The Soviet program, insulated from these pressures by its institutional structure, continued. The race was not publicized in the way that the space race was. But within the geoscientific community, the Kola project represented the Earth science equivalent of a moon landing, an attempt to reach an environment that theory described but observation had never verified. The Kola borehole descended through the Baltic Shield, an ancient Precambrian craton, one of the stable cores of the Eurasian continent, at a pace of roughly 1,500 meters per year in its productive early years, slowing significantly as depth increased and the engineering challenges of operating at extreme pressure and temperature multiplied. The first major surprise came at approximately 7 kilometers depth, where the predicted Conrad discontinuity, the boundary between granitic upper crust and basaltic lower crust, that every geological textbook of the era described, simply did not appear. The drill passed through 7 kilometers without encountering the expected change in rock type. The rocks below the predicted boundary were not basalt. They were still granite, metamorphosed, heavily fractured, ancient granite, but granite nonetheless. The seismic signal that had been interpreted as a rock-type transition was, in reality, a metamorphic transition, a change in the physical state of the same rock type caused by increasing pressure and temperature, not a change in composition. The Conrad discontinuity, as a compositional boundary in continental crust, did not exist. This single finding required a significant revision of crustal models that had been developed and taught across 20 years of geological education. It meant that the deep continental crust was structurally different from what seismic analysis alone had suggested, a lesson in the limits of indirect inference that remains directly relevant to contemporary debates about the deep structure of other tectonic environments. The second surprise was thermal. At 12 kilometers depth, the temperature of the surrounding rock was measured at approximately 180 degrees Celsius, nearly double the figure that thermal gradient models had projected for that depth. The standard assumption of a linear geothermal gradient based on surface heat flow measurements and extrapolated downward had underestimated the actual temperature by a factor that made continued drilling mechanically impossible. The drill pipe itself, under the combination of extreme heat, pressure, and the mechanical stress of rotating through fractured rock kilometers below the surface, became increasingly prone to failure. At 12,262 meters, a section of drill pipe twisted and broke, the stuck portion could not be retrieved, and the viable borehole depth was effectively established by equipment failure rather than engineering decision. The third and most scientifically resonant discovery was water. At depths below 7 kilometers, in rock that had formed under conditions of extreme temperature and pressure that should have expelled any free water billions of years ago, the drill cores recovered water-saturated rock, not water that had infiltrated from the surface, not groundwater that had percolated downward through fractures over geological time. Isotopic analysis of the water confirmed that it was of deep crustal origin, produced by the chemical interaction of minerals with hydrogen and oxygen atoms locked in the rock structure itself during metamorphic processes. The water had been generated in place, in the deep crust, by geology rather than by surface hydrology. To feel what this means physically, imagine a rock that has been compressed under a weight equivalent to stacking 350 kilometers of continental rock above it, at a temperature hot enough to soften lead, for hundreds of millions of years. Common intuition says that rock would be bone dry, every molecule of water squeezed out long ago. The Kohler data says the opposite. The deep crust generates its own water, and the implications of that finding extend far beyond the Kohler Peninsula. The Kohler project's most significant crisis was not scientific. It was institutional. The program had been designed within a Soviet scientific framework that insulated it from the cost pressures and timeline accountability that governed Western research programs. Through the 1970s and 1980s, this insulation was a strength. It allowed the program to continue through the setbacks, equipment failures, and extended periods of slow progress that would have terminated a commercially accountable project. The dissolution of the Soviet Union in 1991 removed that insulation entirely. The Russian Federation that inherited the Kohler facility inherited it without the institutional structure that had funded and administered it, without the political priority that had justified its budget, and without a scientific establishment capable of maintaining the commitment. The program formally ended in 1992. The facility was formally closed in 2008. By the time international scientists sought access to the site for follow-up research, access that the Soviet program had deliberately restricted, with core samples and data shared selectively and partially with the international community, the facility had deteriorated to a state of advanced disrepair. Equipment had been stripped or had corroded. Documentation was incomplete. The borehole itself, once a precisely engineered scientific instrument, had been sealed not as a deliberate archival decision, but as an administrative conclusion, a hole that had served its purpose and whose continued existence required maintenance that no remaining institution was prepared to fund. What was sealed inside was not merely rock and water and darkness. What was sealed inside was an unfinished experiment, a 24-year investigation that had answered some of geology's most fundamental questions and generated new ones that the program had not survived long enough to pursue. The data produced by the Kohler borehole was genuinely transformative for crustal geology. The Conrad discontinuity revision propagated through the geological literature and reshaped theoretical models of continental crust composition. The deep crustal water discovery influenced subsequent research into deep subsurface microbiology, the emerging understanding that microbial life exists in the deep crust, sustained by chemical energy rather than sunlight, at depths and temperatures that previously would have been considered incompatible with biology. But the distribution of this knowledge was incomplete in ways that still matter. The Soviet scientific program published selectively in Russian language journals, translated partially and irregularly into the international literature. Core samples, the physical record of what the drill encountered, were archived at the Koller Science Center, but were never systematically integrated into the global geological sample repository networks that preserve and make accessible the physical record of Earth science exploration. The full dataset, the complete record of 24 years of drilling, logging, and core analysis, has never been comprehensively digitized, translated, and made accessible to the international research community. This is not a conspiracy. It is the normal casualty of institutional collapse. When a scientific program ends abruptly without adequate archival infrastructure, the knowledge it produced does not become classified. It simply becomes inaccessible, scattered across formats languages, and institutional memories that disperse as the people who held them retire or die. The cola data is not suppressed. It is, in significant portions, simply lost to the practical inaccessibility of institutional entropy. The cola borehole's deepest legacy for contemporary Earth science is methodological. It demonstrated, with physical samples and physical measurements, that the models derived from indirect observation of the deep crust were wrong in specific, correctable, and scientifically productive ways. It established that the deep continental crust is wetter, hotter, and structurally different from theoretical prediction, and that these differences have implications for everything from the origin of crustal fluids to the potential depth range of subsurface microbial life. The International Continental Scientific Drilling Program, established in the 1990s as a multilateral successor to both the COLA project and various national deep drilling initiatives, has continued the work of direct crustal sampling at sites around the world. The Chinese Scientific Drilling Project, the German Continental Deep Drilling Program, and ongoing oceanic drilling through the International Ocean Discovery Program collectively represent the continuation of the scientific imperative that the COLA project demonstrated. That the interior of the Earth cannot be understood through surface observation alone, and that every kilometer of direct access to the deep crust produces knowledge that indirect methods cannot replicate. None of these successor programs has approached the COLA depth. The technical challenges of drilling to 12 kilometers in crystalline basement rock, the heat, the pressure, the mechanical stress on drill strings kilometers long, the difficulty of maintaining borehole stability in fractured rock at extreme depth, remain at the edge of what current engineering can sustain. A successor program to the Kola borehole, proposed within the Russian scientific community and discussed in international drilling forums, has never been funded to the point of implementation. The deepest point ever reached by human engineering sits beneath a rusted cap in the Arctic. Sealed. There is a particular quality of knowledge that can only be obtained by going somewhere, not modeling it, not inferring it from a distance, not constructing a theoretical framework elegant enough that its predictions feel like facts. The Kola Superdeep borehole was, in its most essential character, an act of going somewhere that no instrument had ever gone, and returning with what was actually there rather than what the models said should be there. What was actually there was more complex, more water-saturated, hotter, and more structurally surprising than 20 years of theoretical geology had predicted. This is not a failure of science. It is science operating correctly, producing observations that challenge existing models, forcing revision, generating new questions that the observations alone cannot answer. The welded cap on the Kola Peninsula does not mark the end of a question. It marks the depth to which one generation of scientists was able to push before the institutional structures that made the pushing possible collapsed around them. The rock below the cap has not changed. The water the drill encountered at 12 kilometers has not evaporated. The geological formations that formed 2.7 billion years ago are not waiting with any urgency for the next instrument to reach them. They are simply there, as they have always been, as they will be long after the rusted cap above them corrodes entirely and falls away, holding the answers to questions that another generation of scientists has not yet assembled the will and the resources to ask again. The deepest hole ever drilled is not what it found that defines it. It is the distance between what was expected and what was encountered, 12 kilometers down, in the dark, in the heat, in rock that was wet when it should have been dry. That reveals what the planet has always been, older, stranger, and more generative than any model built from the surface has. The resolution to contain. The Earth does not fit the map.